Welcome to qnawire.
Hi, so over here we have the following data for strontium. We are given the electronegativity, electronaffinity, ionization energy, and heat of fusion, and we're asked some question about it. So first of all, let's remember the definition for electron affinity. Actually, since I'm looking that the result that is given to you is positive, I know that the definition that was given may be different from other sources. So in general, if you look up the electron affinity for strontium, you're going to find a value of minus 5.03. But in this case, the definition that your professor is employing is the following. X plus one electron produces X minus plus energy. And the affinity for your professor is defined as minus the delta H for the reaction. In a lot of sources, they do not employ this definition like this, and directly the electron affinity is given as the value of delta H. Okay? But regardless, with this, we know that in the electron affinity, what is going to happen is that energy is going to be released. Now, in which cases the electron affinity is not going to release energy? In general, that is going to happen for noble gases. And you can actually look at a graph that shows the electron affinity as a function of the atomic number. And you're going to see in which cases the electron affinity is actually, you actually require energy for that. Next up, we're going to have the definition for the ionization energy. And in that case, it is more simple. You need to provide energy, and in particular, this energy corresponds to the ionization energy. To produce X plus one electron. Okay? So now with this, we can replace, instead of using an element X, we can directly put the values for strontium. Whoop, let's get rid of this. Strontium, strontium, strontium minus, and the strontium plus. So now, with this information, for this first reaction, this corresponds and is the same as the ionization energy. So we know that we need to absorb energy. Is it possible to calculate the amount of energy absorbed or released by reaction 1? Yes. What is the answer to that? That is directly the ionization energy. So we need to absorb 549.5 kilojoules per mole. And for the next one, we are going to have the electron affinity, as you can see. So for the electron affinity, we're going to release energy. We can calculate this, and the result is equal to 5.03 kilojoules per mole directly. And that will be all. Thank you very much.